Mars has always captivated human imagination, and as science advances, it captivates us more and more. In our search for knowledge, the desire for colonizing new worlds appeared, and Mars emerged as the most feasible option due to its closeness and similarities with Earth. International cooperation is vital to reach Mars. This was understood by 14 special agencies around the world, and as a result, the Global Exploration Roadmap was delivered. In this plans the route for 6 lunar space explorations that will prepare us to go to Mars while bringing these benefits to humanity. Expand human presence in solar system, understand our place in the universe, foster international cooperation, engage the public, and stimulate economic prosperity, generating new business opportunities that some companies are already taking. Like Boeing, who manufactures new and better boost systems, or Mars One, which plans to transmit every stage of the mission for a self-sustainable colony in Martian land, or even SpaceX, who made its story recently with the selling of the first commercial spaceflight. My name is Geraldine Lomelí, and this is my team.
For us, it seems quite paradoxically to insert a self-sustainable colony in Mars when we are losing our sustainability here on Earth. Livestock by itself generates 240 billion of tons of CO2 annually. From it, the 24% are caused by the decomposition of the excrete, producing 57.6 billion of tons of this greenhouse gas. To put it in perspective, this is the Antonov, the heaviest airplane ever constructed, with 640 tons of weight. To match the weight of the total emissions, it will be required more than 90,000 Antonov airplanes. So we started asking us how space exploration could help us in the solution of this problem. And the in-situ resources utilization system has captivated our attention. In the GER vision of establishing space colonies, the ISRU is fundamental. Science, it will provide the colony of oxygen, fuel, and construction material through the processing of Martian regolith. More specifically, transforming CO2 and water, both abundant in Martian atmosphere, into oxygen and methane. Our proposal is to use this technology to transform animal excretes into fuel. The animal excretes are buried in a deposit tank and mixed with water. The methagenic bacteria will decompose the material, generating biogas. As it is methane mixed with CO2, it will be necessary to use a separation column with water. The methane will reach the top of the column while the water will capture CO2. Water and CO2 will be separated using their boiling and condensation differences. Once separated, water and CO2 will enter in a photoelectrochemical cell, which splits water into hydrogen and oxygen, and CO2 into oxygen and carbon. Using photoenergy combined with the reaction produced by an anion and a cation made of titanium, the final result is fuel and oxygen production.
With the commercialization of these systems and an eventual partnership with food industry, strongly dependent governments, we could generate financial support for exploration and technology development, generate an intercooperation network to improve the system efficiency and make it viable to go to Mars.
The Martian race needs brave and innovative persons, and we are ready to take the challenge.